1, 2, 3 actually represent the elements of that set. And so suppose this is the set A. Now 1, 2, 3 are the elements of the set A. When I represent this on a, let's say, Venn diagram, so first thing is, this is outside is your universal set. This is your universal set. Universal set. And what we get is inside, let's say set A is 1, 2, and 3. This is set A. Now, when I talk about the number of elements in set A, so that will be represented by NA. So number of elements in set A means how many elements are there in set A. So you will say 3 elements. And when they say list those elements, then you will say, okay, those numbers are 1, 2, and 3. So that's how you firstly do the listing of the elements. Now comes is the second part, is sometimes like tackling the equations, sometimes different types of like, conditions in order to interpret what elements are. So for example, sometimes they'll give like, okay, set A is the numbers which is such that X is such that X is between, X are the numbers between, X are integers, you can say integers, between um, 3 to 7. Now they'll just say this. Now, when X are the set of the integers between 3 and 7, you should be able to simplify that those numbers, integer numbers are going to be, so the writing this or equivalent set will be like 4, 5, and 6. So these will be the elements of the set A. We won't include 3 and 7 because they are not included. If we would have given the equals to here, in that case even 3 and 7 would come. So this is the general way of interpreting the elements of a set. Now, coming back to the other key terms, let's talk about some of the main key terms. Number one is the uh, let's say universal set. Then you have universal set. Then you have after this you have complement. Then you have, let's say, intersection of the sets, intersection, and then you have union. So now when you first talk about the complement set, like when you have a particular set given, and complement is everything apart from that, those elements which are there in the set A. So let's say if you use the universal set that is representing outside, A complement will be everything that is outside. Now, for example, in this universal set, we have, let's say 1, 2, 3, 4, and 5. And if in set A we have got 1, 2, 3. So if in set A we have 1, 2, and 3, and in universal set we have 4 and 5. So we'll be representing this as like 4 and 5 somewhere outside. So when you talk about the numbers in a set, you never repeat them. You can't say, okay, there'll be 1, 2, 3 here also, then you're repeating it. So that's not possible. So what you do is, whichever numbers are not there in set A, I mean, obviously they are also part of universal set. So automatically here you see that A is part of the universal set. So it means that 1, 2, 3, 4, and 5, this will be the universal set. Now, when I say A complement elements will be 4 and 5. So everything that is outside A is called as a complement. So this is important to understand what actually complement means, that everything outside that set is referred as the complement. Let's go to the next part. Now, for example, let's say this is not exactly the complement. Now, these are the, let's say, triangle and square, and here are some of the notations. Use the diagram to determine each of the following sets. Like in U, we have basically a square, then a triangle, dollar, M, and 5. While in set A, we have, that is, in set A, we have uh, like the elements is square and the triangle, and the set of the elements that in U that are not in A, which is complement of A. So A complement, when you talk about, that is these three elements, which are dollar, M, and 5. So these are going to be the basic uh, complement elements. So complement is shown by this A and dash on the top. So just be wary of that as well. Now, when you talk about intersection, actually, or like some of the other key terms. So one thing is that when the two of the sets are disjoint, like you see that there is no overlap between them. When two sets are equal, then they are just one above other. Means um, what happened is that in number of elements are also the same, and the elements, the face value of those elements is also the same. When there are proper subsets, so in that case, one of the set is exactly inside the other. Like for example, if I have set A is, let's say, 1, 2, 3, and set B is basically 1, 2, 3, and 4. So 1, 2, 3 is here, 1, 2, 3 is here, and 4 is actually here. So in that case, you have the proper subset. Now, when you have overlap, this part is called as intersection. Now, intersection is always, you can remember that is the common elements between both. So intersection is like which elements are between A and B. So intersection is also referred as a key term when you refer. Intersection is referred as and. So when your intersection you talk about, just remember that and is the key term that is for the uh, intersection, and obviously the overlap is referred as the intersection part. Now, the next part is to actually understand um, with the one of the examples. So now if you see here, let's just, this part is representing only A. So the set A, B are there, where D is the common element. And if you notice, A, B, and C, they are the elements of only A. E is the only B, and D is between A and B. So when we write down the intersection, it will be A intersection B will be basically nothing but the D. Here, let's say ABC, I'm not considering these as elements, I'm just considering these as a region uh, uh, for this. But if we consider them as also the elements, in that case, A intersection B. So A intersection B in that case is going to be the 2 and D as well. And if you consider the first part, which is only A, this will be only A will be 1A, B, and C, and only B will be 3 and E, and obviously when you have A union B, now A union B is like um, this entire set is referred as A union B, like which elements are in A or B. So union always represents or, union is always or, intersection is always and. So which elements are in A and B is intersection, which elements are in A or B, that's your union. So when you talk about the union, actually is everything that is in common, I mean that is between both the elements, whether it is A or B or in both of them. So when you talk about here the A union B, in this case, we'll talk a little bit later also, but A union B will have these elements as uh, A, B, C, 2, and D, and 3, and E. So these are going to be the elements in that set. So let's just answer the questions now. Answers for elements for U are going to be, okay, so these are not the, as correctly pointed out, these are not the reason, these are just like the regions to represent. So when you talk about the elements, only A, B, C, D, E, F, and G, these are the numbers that we would talk about. Set B will have D and E. Set in B you have, you can see D and E. Set A has which is write down the set of elements in U that are not in B. So not in B will be complement of B basically. This is also, you can say this is called as B complement. And the set of elements that are in both A and B. So obviously that is nothing but D. So you can see that these are the answers that you have. Now, Coming to the complement, as we discussed this, we already have done. Now, anything outside the set A will be the complement. So 1, 2, 3, 4 are the set elements, but rest of them are going to be the complement, which is 2, 5, 6, 8, and 9. So this is fine. Now, there are a couple of examples on intersection of the two sets. So let's say here, when you talk about the intersection, obviously it's, you can see 8 and 8 and 10 and 10. These are the two intersecting elements. So that will be in the intersection of the two sets. So that's this part of the intersection. And so if we have 8 and 10, there is, if there is nothing in intersection, you write down this as null set. And here, like a set within other null set will have obviously null set as an intersection. Now union. Now when you talk about union, obviously you combine the elements. Union means first set or second set, which, and then you, whichever numbers are getting repeated, you just make sure that you write them only once. So you can see that 6 is there, so 6 is there, then 7 is there, then 8 is there in both, so you just write it once, you don't need to write twice. Then you say 9 is there, and then 10 is there, and then you have 11 and 12. So this is, these are the elements of the set A. A and B means if you combine them, that's what you'll get. So that's how you write down the union. So first set, the union is here in this case is as we written here. Second, 1, 2, 3, 4, 5, 6, and 7, and 8, and until 9, because there none of the elements are repeated. Here, if you combine a set with the another empty set, obviously the same set you'll get. So union actually also is referred as a combining element, like combine the elements. Intersection is pick up those which are common between them. So that's how we interpret the basic key terminologies. So let's say here you can see A union B complement. So first we find out A union B. So let's say A union B here will be 1, 3. So 3 is twice. You write this one. 7, 8, 9, and 10. So that's your A union B. Now, when you write down A union B, in this case, if I write down the complement of that, so see, one is, so from universal set, cut down those elements that are not in A union B. So one is already there, so that is not going to be this. 2 is not there, so 2. Then 3 we don't have. I mean 3 we have. Then 4 we don't have. 5 we don't have in A union B. 6 we don't have. 7, 8, 9, and 10 we have. So when you write an A union B complement, it'll be 4, 5, 6, and of course 2. So this is going to be A union B complement. So it's like which elements that you have is not in A or B. I mean A or B, which is, I mean, outside A or B basically. So that those are going to be these elements. Now coming back to the second part, which is basically this one, A complement intersection B complement. So A complement means everything that is outside A. So A complement is going to be um, so A complement is going to be 1, 3, 7, and 9. So 1, 3, 7, and 9. So after leave 1, 3, 7, and 9. So cut down all the numbers from here. So it'll be 2, 4, 5, 6, 8, and 10. So 2, 4, 5, 6, 8, and 10. That's A complement. And then B complement is going to be, skip out the numbers that are in B. So 3, 7, 8, and 10. So it'll be 1, 2, 5, 6, and 9. So 1, 2, 5, 6, and 9. And now you're going to see which numbers are common in both. So A complement intersection B complement. So which numbers are common in both. So now intersection is like common. So you see that, okay, so 1 is not there, 2 is there. So you're going to be 2, 5 is there. So that's 5, 6 is there. So 6, then 4 is not there. I think 4 doesn't seem to be there. So 2, 5, 6, and B complement. So 4 will also come in the B complement. So it'll be here. And so the 4 also is going to be there. So these are going to be the elements in the A complement intersection B complement. So which numbers are common? in A complement and B complement. So if I have to represent this on Venn diagram, basically, it becomes very interesting. So now, when you talk about A union B, which if you look at this as a summary, A union B, it will be the set of elements that are in A or B or both. So that is this entire set. So that is this part, which is like 1, 2, and 3. Region 1, 2, and 3, if we combine together, so that's A union B. A union B complement will be everything outside A union B, means it is out here. This set, this region is called as A union B complement. That is only region 4. Then we got A intersection B, that is only this part, which is obvious. Then we got A intersection B complement. So A intersection B we already have. So everything outside this will be called as the A intersection B complement. So that will be this part here. And so that will be the, if you, in case if you have to do shading, that's the part that we're looking forward to. Then we got A complement intersection B. Now, how do I read this? A complement means which elements are not in A but are common with B. So which elements are not in A, if I look at, but in common with B is only this part that you see, only third. Not in A, intersection means common. So not in A, but common with B. So not in A means everything outside A and common with B. So that's only only this region that I've shaded here. So that is this part. Another, this part which we have got is A union B complement. So when you talk about A union B complement, so A union B complement means which region basically is outside B and combined with A. So outside B, and when you combine with A, so outside B will be basically all these parts. Let's say outside B is this part, and that's B complement. And if I combine this part with A, basically my this element also come back, because even though that is not part of B, I mean obviously due to your combining with A, it comes back. So how do we read this? Which, if I read the F part, it'll be which elements are in A along with the numbers that are not in B. So A, obviously the entire set has to come, or the numbers that are not in B. So these numbers, yes, they're not part of the B, but they are part of the A here in this part, if you see. So that's where that region also comes, and you need to be careful when you're analyzing this.